All right, so picking back up here a little bit on this range idea, sometimes it's really, really useful to be able to count backwards, right? So sometimes you want to start at the end of a list and count backwards, okay? You can actually throw the step value a negative number, and it'll start at the end and work its way back. So obviously at this point, it would start at 10, it would go down by 1, and then it would go ahead and stop at 1, right? Because the ending point's not inclusive. Okay, so you can actually make it go backwards using this negative stepwise value. All right, so we're going to jump here into this concept of calculating running total. So let's say we want to find the average of something, right? The first step you have to do in finding an average is getting a total summation and a count, right? So if I wanted to find the average of 3 numbers, and those numbers are 10, 10, and 10, I would do 10 plus 10 plus 10 divided by 3, right? There are 3 values, and I add all those values up, okay? So same thing with this whole running total idea. So if I have a set of numbers, it's nice to be able to add those up, okay? So we can actually do this thing called calculating running total. So what it does is it uses a loop that reads each number in a series and then it accumulates that number into it using the identity of it, okay? Or you initialize it to the identity. So the additive identity is 0, right? The multiplicative identity is 1. Okay, so if we're accumulating, we're going to set our accumulator to 0. So the basket is empty. And then we're going to add values to it, which we're just going to add, so the first value coming in is 100, we're going to add 100, and then we're going to add 52, and then we're going to add 65, and these random numbers that are coming in. And at the end of the loop, the accumulator will have the total values, okay? So that's sort of what the accumulator does. So essentially, you set the accumulator to 0, which is the additive identity, okay? Is there another number to read? Yes, read the number, add the number to the accumulator, and then keep on rolling through that, okay? So to show you what that accumulation sort of looks like, what we could do is we can go ahead and set a accumulator. So let's say we'll call it a cum, and we'll set that to 0. Okay. So let's say we want to take 10 values. So we're going to go for x in range. We're going to go 10 times. Okay. So then we're going to ask the user to enter a value. So we're going to say a cum. We're going to ask the user. Obviously, we're going to use this right here. Enter a value. Okay, now we want to convert that to an integer because we just want to force them to use an integer. Okay, so now we're going to have an integer. Now what we want to do is we want to place that value into the accumulator. And we can do that by doing this little thing right here, plus equals. That is the same thing as a cum plus that. Okay, so it'll grab the value out of a cum. So let's say that value is 100. It'll put 100 here, and then it'll add that value that's getting added. Okay, so we can actually use the plus equals value. Okay, so now that accumulator is just going to keep adding and adding and adding and adding. And then once we're done, we can go ahead and print that accumulator out and see the total. So let's just do something that we can very muchly predict. So we're going to enter 1 10 times. All right, so we have 10. Okay, so let's do something a little bit less lengthy. We'll do 3. So let's go ahead and run this 3 times. Let's add 10, 10, and 10. So we know we're going to get 30. Let's do 5, 5, and 5. We know we get 15. Okay. So what's interesting is we can actually have a number that we get the user to add in there, right? So count equals int input. Oops. Man, I can't type today. Input. And then we can actually say enter number of values you wish to add. Okay, so we can actually use that. And then in this range, we can actually use count there. Okay, so then it'll go the many times as I want to. The cool thing about that is then if I want to get the average or the mean, right, mean, then I would simply take accumulator divided by count, right? And then I can go ahead and print mean. Okay, so I can find the average of any set, right? So enter number of values, we're going to go 3. So we're going to enter, we'll pretend it's like tests, 95 or 92, 98, 85. Okay, so 91.666667 is what we end up getting at the end. Okay, so we actually have an average, right? So we can say, okay, there are 15 tests. Well, let's just say there are 5 tests. Okay, and you got a 98 and a 90. Let's just say they're all 98, right? We know that the average should be 98, correct? So that's actually a nice little way to find a mean or an average of a data set, okay? And you can actually see that using this accumulator, okay? And what's happening in this is I set the accumulator to 0, which is additive identity, and then I ask the user how many values you want to enter, and then I actually say, hey, give me the first value. It returns it as a string, convert that to an integer, and add that to what's already in accumulate. That's what this plus equals is, okay? And then at the end, I make the mean as accum divided by count. All right? So that's sort of the way that is going to work in a general sense there. Okay, so the augmented assignment operator sort of allows you to make things a little faster. You actually saw one of them already. The plus equal operator is the same as x equals x plus 5. Okay, the minus equals is y equals y minus 2. Okay, so I want you to get these in your head. Essentially, it's the same thing. So, you know, x equals x times something. X equals x divided by something. X equals x modulo something, right? So c equals c modulo 3. X equals x integer division 3, so on and so forth. Okay, so these are the augmented assignment operators. Obviously, we saw those as I was coding things right over here. Okay, so the accumulator is using this plus equal augmented assignment, okay? And that means we're doing the same thing as accum equals accum plus this value that's getting entered. Okay, that's that plus equal. So I want you to get those through your head. I want you to go ahead and play around with those a little bit, all right? So the next kind of concept is we have this accumulator. We know we can accumulate a bunch of numbers, say from a data set or from a user entering numbers. We also have things called sentinels. Sentinels are like special values that marks the end of a sequence of items. So when a program reaches a sentinel, it basically knows that it's the end of the sequence of items, right? And the loop terminates. So it needs to be distinctive enough so as to not be mistaken. So like an empty line will terminate, or you can have a user enter Q to go ahead and terminate some sort of a loop. All right, so coming over here to PyCharm, we can actually look at a sentinel, okay? And a lot of times we'll use while loops for sentinels. So let's say we want to ask the user to input their name or names, right? So we could say input enter a name, right? So as we run this, you know, we can get a name, right? Adam. There we go. Stored Adam. Let's say we just want to be able to loop and enter name after name after name after name until they hit Q. If name equals Q, terminated. Okay? So let's think about how we could do that. Well, if the condition of name is Q, then terminate. So if it's a condition controlled loop, we're going to use a while loop, right? Just like such. Okay? So while name is not equal to Q, we loop, right? So we're just going to do, we're going to print the name, and then we're going to go ahead and have them enter another name, right? There we go, okay? So what's going to happen is it's going to print out Adam, and then it's going to say, hey, enter another name. And I say John. It's going to come back and say, John is not equal to Q, so let's do it. Steve, you know, Sharon, Jerry, Katie, whatever, all these names. If I finally hit Q, then it should quit. So let's run this. So here's Adam. Great. Here's Steve. Great. Here's John. Here is Sharon. All right. Here's Q. Boom. Okay, so Q serves as a sentinel. Now, one way we can do this is we can call it sent, and we can actually just give it a value, right? So we can establish the sentinel value just like such. And actually, we can call it sentinel. Just like such. Okay, so now I can make that variable if I want to. So I can even ask the user input enter a sentinel value. Okay, so now the user is the one that actually gets to choose where it ends. All right, so enter a name, and I would actually turn these around if I was making an actual program. Sentinel value, let's say it's X. Okay, so now I can enter Steve. I can enter pretty much anything, honestly. Whatever, doesn't really matter. It'll print it out until I hit X, and then it goes away. Okay, so that's what a sentinel is, and that's what a sentinel loop is. Okay, now input validation loops is a sort of a modification. It's a lot like a sentinel loop. So when a user puts data in, we don't really know what that data is. And oftentimes as you get more and more experience with computer programming, you're going to realize user input is one of the most intimidating, terrifying things ever, right? Because users can put in all kinds of crazy values. And sometimes we want to make sure that we limit what they can put in and we make sure that they're putting things in correctly. Okay. So essentially a computer cannot tell the difference between good and bad data. So that means if there's bad input, the program is going to produce bad output, right? Garbage in, garbage out. So it's important to create these loops that make sure that the user is putting in stuff that we want them to be putting in. So what ends up happening is we do something called input validation, which is inspecting the input before it's processed by the program. So let's say we want them to enter either yes or no, and they enter bad. We want it to just keep looping until they enter either yes or no. That's what an input validation loop is going to do, right? So we get the input. Is the input bad? Yes, it's bad. Display the error message, get the input, and just loop and 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 loop. Okay? So here's the way that we would do input validation. Okay, so we would say user input. Okay, what we want them to do is we want them to enter yes or no. Enter yes or no. That's all we want. Okay, so obviously with this happening, I can print user input, we can run it, and we can see yes, great. We can see no, great. But what's stopping me from putting in car? Nothing, right? I mean, it just does whatever. So I need to check that, okay? And the way that I can check that is, again, it's a condition, right? So while user input is not equal to yes, okay? So we know that we've included yes while it's not, and we'll experiment with this a little bit too. While it's not equal to yes, and while it's not equal to no, right? User input is not equal to no, because we want yes and no. And we're going to see if this logically works. We're going to test this out. I want you to think about this a little bit. You're going to re-ask the user for the input, right? Enter yes or no. Okay, and I want you to think about this logically and think, and then on the outside we'll say, good job. Okay, so let's just test this. I mean, we can think about it. We can sort of digest it and figure it out, but let's go ahead and just run it and see what happens. Okay, so I'll enter yes. So that's not really working. Let's enter no. That's not working. Oh, you remember how the comparisons are case sensitive, right? All right, let's try lowercase yes. All right, that seemed to work. So let's try it again with lowercase no. Good job, excellent. So let's try it with some bad input. Cat, nope. Dog, nope. Go. Let's go with a capital yes. Capital no, nope. Just a lowercase no, or a lowercase yes. Okay, so what ended up happening is we asked them to enter yes or no, and then we use this while loop to validate that. Okay, now the last thing for this chapter that we're going to talk about is this idea of nested loops, and I'm going to give you a little bit of a break. We're at 14 minutes, so we're going to have one more video covering nested loops, and then you'll be all done for chapter 4. So we'll be right back on the other side.